Now, if you are talking about consequential uncertainties, what you're trying to say is if you have two or more values that have uncertainties and you choose to add them up together or subtract them or multiply them or divide them. So all these values got uncertainties. So when you find when you add them up together or minus or times or divide, your uncertainties will become more or less. Can it be more certain? If you're taking two values which is not certain, when you plus, of course you get more uncertain, right? You're increasing the uncertainty mark. If one value is already not certain, the other one also uncertain. When you add, you get even more uncertain. But when you minus, it's also more uncertain. That means you cannot say, oh, my first value I got plus minus 0.01, second value I got plus minus 0.01. When I minus, I get 100% accurate. Does that make sense? It doesn't make sense, right? So the idea is, when you plus or minus, so the first one is called addition and subtraction. So let's say if you got two quantities, let's say you got A, fine. So when you take, like, for example, A plus minus delta A and B plus minus delta B, if you add them up together, let's say your Y equals to A plus B, or you minus them, let's say Y equals to A minus B, the uncertainty of Y is still delta A plus delta B. That means your uncertainty in your final answer you must add up. Whether you plus or minus two quantities, the uncertainty has to add up. But this only applies if you plus or minus, okay? For example, when you're measuring length, do you realize that if you use a ruler to measure length, the uncertainty is plus minus 0.1 centimeters? Now, why is it like this? Okay, the example is like this. Now, let's say you have a book that you want to measure the length, right? So what you will do is you will place your ruler beside your book, okay? Now, you will try to align one end of the book to the 0 mark, and then another mark you will see how what is the length. So because the every point that you align, which is here and here, has an uncertainty of plus minus 0.05, because this is considered a pointer reading and this is also considered a pointer reading. So let's say you get 0.00 plus minus 0.05, right? So that represents this reading. So what about this here? So let's say here you get 11.40 plus minus 0.05. So what is the length of the book? You would have to take this value and subtract this value. So when you subtract, you will actually end up with 11.4, and the uncertainty has to be added up, so it's plus minus 0.1 centimeters, which is why usually the length of anything that you measure, or the distance that you measure using ruler or meter rule, is actually actually has an uncertainty of plus minus 0.1 centimeters. Now, what about the case when you multiply or divide two quantities? Now, remember just now we had A plus minus delta A and B plus minus delta B. So if you take both of them and you multiply, or you take A divided by B, now the only way to find the uncertainty for Y is to first find the fractional uncertainty or the percentage uncertainty. And how you will do that is to add up their fractional uncertainties or percentage uncertainties. For example, here you would write as delta Y over Y equals to delta A over A plus delta B over B. So whether you multiply or divide, you will still have to find the fractional uncertainty of Y first by adding the fractional uncertainty of A and the fractional uncertainty for B, which is the same for both, even if you divide. Now, there is a choice that if the question asks you to find the percentage uncertainty instead, then you can write in terms of percentage uncertainty. Because if you think about it, we can actually take this whole thing and times 100, then you get the percentage uncertainty for Y, and this whole thing we can multiply by 100 to get the percentage uncertainty for A plus the percentage uncertainty for B, which means to say it will end up as delta Y over Y times 100 equals to delta A over A times 100 plus delta B over B times 100. So when will this be useful? This will be useful when they give you the values of the percentage uncertainties. Then you can just add them up together to get the percentage uncertainty for Y. Now, if the question asks you for the fractional uncertainty in y, then you can just add up these two and that will be your answer. But if the question asks you for percentage uncertainty in y, then you add up the percentage uncertainty for this and this will be your answer. But if the question continues by asking you the absolute or the actual uncertainty in y, then we have to bring the y over. Example, so your uncertainty, actual uncertainty for y will be a delta a over a plus delta b over b multiplied by y. And in this second case, your uncertainty for y will be equal to the percentage uncertainty for a plus the percentage uncertainty for b. Then you bring the 100 over, that means the whole thing here, you have to divide by 100 first, then the whole thing times your y. Then you will get the absolute uncertainty for y. So before you actually bring the y over here, or you bring the 100 and the y over, check and see whether the question requires you to find fractional uncertainty, percentage uncertainty, or absolute uncertainty. Now, if let's say your equation involves power, for example, y equals to a squared times b cubed, so there's a power there, or y equals to a squared over b cubed. Now what do we do with the power? Now if you want to see, you can break it down to a times b times b, times b, right? If we use back our previous formula, then it will be delta y over y equals to delta a over a plus delta a over a plus delta b over b plus delta b over b plus delta b over b. Correct or not? Which do you notice you can group these two together and you get what? 2 delta a over a. Can you see you can group these three together and you get 3 delta b over b, right or not? Which is actually a shortcut. If you don't want to do such a long way, you see got power, you bring it down. So 2 delta a over a. Power, bring it down. 3 delta b over b. Understand that? So it actually comes from here, but you can bring the power down. So whether you times or divide, same thing, you will only add the fractional or percentage uncertainty. Do you understand that? Okay? Now the fourth rule that we're going to have is when, let's say you have the value of a plus minus delta a, so this is a plus minus delta a, and then you want to find y as 4a or y equals to a over 4. Now there are two ways to find the uncertainty in y. The long way is to actually write down in terms of fractional uncertainty. Delta y over y equals to delta a over a. And then from there, you bring the y over and then you can get the delta y. But this way is more complicated. The easier way is to actually write y equals to 4 and then you substitute the a as plus minus delta a plus minus delta a. So therefore your y will be equals to 4a and the uncertainty will be 4 delta a. Alright, in that example, now let's say you had 4 balls that you had the total diameter as capital D, and let's say it gave you 4.0, capital D is 4.0 plus minus 0.4, and you wanted to find the diameter of only one of the ball, which is small d. So the formula for small d, isn't it capital D over 4? So using the long way, then you will write as delta d over d equals to delta big D over big D, which will give you delta small d as the delta big D is 0.4 over the big D, which is 4, then times the small d, which will give you equals to 0.1. Alright, now the shortcut is to basically just take the 1 over 4 out and then put the 4.0 plus minus 0.4, and you will end up as 1.0 plus minus 0.1. So you will end up having the same uncertainty if you use both methods. Now one example is like sometimes when they ask you to find the area of a circle, so everybody knows the formula is pi r squared, but what they gave you, instead of radius, they give you diameter. Let's say the diameter is 2.0 plus minus 0.1 centimeters. Now many people would just say, oh, a equals to pi r squared, so I will just take pi times half of it, 1.0 squared. And when I ask them for uncertainty, well, the diameter, since diameter is plus minus 0.1, radius is also plus minus 0.1, which is wrong. Because when you find the radius, which is diameter divided by 2, you must take out the half, then 2.0 plus minus 0.1, so the uncertainty becomes 1. So the radius becomes 1.0 and the uncertainty becomes 0.05. So then the value must follow the decimal place, so the radius is 1.00 plus minus 0.05. So if you did not realize that if you multiply or divide by a constant, and you would have to also change the uncertainty, like in this case, alright, but you took your radius as 1.0 plus minus 0.1 instead of 0.05, then your subsequent values that you calculate will be wrong. For example, if I ask you to find the uncertainty for A, and you didn't realize that the radius has a different uncertainty than the diameter, then you will say, oh, delta A over A equals to 2 delta R over R. And if you did not find the uncertainty for R as plus minus 0.05, but you took it to be the same as the uncertainty for diameter 0.1, so you end up with 0.1 over 1. But if you had realized that the radius has a different uncertainty, so it will be delta A over A equals to 2 delta R over R, which gives you 2 times 0.05 over 1. So you notice that the fractional uncertainty for A is different. If you use the uncertainty as the uncertainty of radius as 0.05 or the uncertainty of your radius as 0.1. So this is obviously wrong, but this is correct. So the best way to calculate area in future, if they give you diameter rather than radius, instead of modifying the value of diameter to become radius, that means you take 1.0, because when you do that, there's a risk that you forget to change the uncertainty. So why don't you actually change the formula to suit your data? So your data is given in diameter, so don't change your diameter to radius to suit the formula, but change your formula to suit your data. Alright, so that means instead of writing pi r squared, they gave me diameter, so I changed radius to diameter. So how do I do that? Since your radius is equals to d diameter divided by 2, then you square it, so you end up with pi d squared over 4. Alright, so by using this formula, pi d squared over 4, then you will avoid the problem of converting your diameter to your radius. But if you want to convert your diameter to radius, go ahead, but don't forget to also find the new uncertainty. So this is the slide that shows you the summary of all the consequential uncertainties, right? So if you plus or minus, you add the uncertainties. If you times and divide, then you add the fractional uncertainties or the percentage uncertainties first. If there's a power involved, then we just bring the power down. And if it is multiply or divide by a constant, you can either use the long way by using fractional uncertainty or taking out the constant and writing the values outside. Then you multiply inside. So these are the 4 formulas.